Hello, my name is Sukaina, and this is my first video. This video is based on the manual written by Dr. Yazan Hussain for the students of Jordan University of Science and Technology, the Chemical Engineering Department. If you're interested in Aspen Plus, I would assume that you are either a chemical engineer or that you're really interesting person. Anyways, I would like to thank Dr. Yazan for allowing us to use his manual as a reference point. At this point, I would recommend that you read actually the first section of the manual called Getting Started, and I will provide the manual link in the comments section. So let's get started. First of all, where do we find the Aspen Plus? So if you downloaded Aspen Plus, you're going to find it in the All Programs, Aspen Tech, Process Modeling. I'm going to use version 8.4. If you're using version 7.4, you shouldn't worry. The same ideas apply. Just go to Aspen Plus, if you can see it here, and Aspen Plus version 8.4. I actually opened it earlier because it takes a bit of time. Not a lot of time, just a bit of time. So if you look at Aspen Plus, you're going to find it interesting. It has file, view, and resources. And what's interesting about Aspen Plus version 8.4 that you can have lots of resources, including training, and you can have all contents. At this point, I'm just going to open a new file. If you look at the new file section, you're going to have a lot of templates. You can have a blank simulation, you can have installed templates, you can have chemical processes, air separation, electrolytes, gas processing, metallurgy, pharmaceuticals, polymers, refinery solids, and user. This is so interesting because actually in Aspen Plus, one of the powerful points is that you can work with your own definite process. If we open a blank simulation, to create a blank simulation, just click on it and create it. Let's see what happens. Okay, if you see here, we have three different tabs. We have properties, simulation, and energy analysis. In the properties, the first thing that opens is the component, type, name, and alias. The methods, which are the property methods that the Aspen Plus would be using to calculate your results. If you click on the simulation tab, you can see that it's a bit different here and a bit different here. Now we have a model palette. We do still have the simulation part here. We still have things here. But right now we have a different like white paper kind of thing. We can draw on it. So what can we draw on it? Everything. We can have work streams, heat streams, and material streams. We can have mixers and splitters. We can have separators, exchangers, heat exchangers, columns, reactors, pressure changers, manipulators, solid separators, and user models, the things that you want to actually have as defined by you. Now, the question written by Dr. Yazan Ahed Hussain in the exercises is a very simple question. He's just using a flash tank, entering 180 Fahrenheit, 20 psi, 50 pound-mole per hour methanol, and 50 pound-mole per hour water. The flash tank produces vapor stream and a liquid stream. It works at a heat duty of 0 and a pressure of 1 atmosphere. So if I wanted to model the simulation written by Dr. Yazan, I would not model. If I wanted to simulate the question written by Dr. Yazan, I would use a flash tank. Now you can see that my mouse turned from a regular mouse, from a regular cruiser, to a black thin cross. If you click again and again and again, you're going to have all these blocks that you're not going to use. So what should you do? Well, first of all, you can have two things. Either you press an escape and your cruiser returns to normal, or you can press a right click and your cruiser returns to normal. If you want to delete them, just select and delete using your own keyboard, okay? So let's put a flash tank and let's make it bigger. And we can rename it and call it flash. I told you already that we have three material streams. We have an inlet stream and an outlet stream and two outlet streams. If you look at the Aspen Plus, every unit will have red arrows in it. Just the second you click the material streams, the unit has red arrows. The red arrows indicate where the feed or the output stream should go. So for example, we have a feed stream that is required. One or more feed streams are okay. In some processes, one stream is the only thing that can actually go into the process. We have a liquid stream that is required and a vapor stream that is required. As you can see, not one or more vapor streams, a single stream. So how do we connect the streams? Well, just click, left click, and move your cursor up. If you find that the red arrow changes color or looks like this, just click another click and you're done. Now your red arrow turned blue. My cursor is still a black cross, so I understand that it's still going to give me material streams if I click anywhere. So let's do this again using the liquid. Right now I want the source of the stream to be from the process. So let's put this to good use. So what if I make another stream but it's not connected to anything? Well, just click on it and you can reconnect it from here. You can reconnect its destination or you can reconnect its source. For our exercise, I'm going to reconnect its source because I want it to be here. So you can see it's like a free now cruiser which I can reconnect anywhere I would like. Let's reconnect it to the stream here. You can actually make your streams look better by just moving them around, okay? So right now I want to rename my stream to feed. Rename my stream to liquid, vapor, sorry. And rename the other stream to liquid. If I want something to be actually customized on the process, I can display anything I want from modify. I can display the temperature and the pressure and the vapor fraction. I can display the heat and work of unit operations. Okay? So now I have a main flow sheet that looks beautiful. I have a flash here. I can put the name wherever I want. I have 3 streams and it looks pretty good. Let's go back to the setup. Let's name our material. If you would look at the setup, it's a file and it contains different files. Now everything here has a blue circle with a check mark on it, with a white check mark. A blue circle with a white check mark indicates that this file does not need any changes and that it's ready to be processed. So why do I have a required input incomplete message? Basically because I didn't input the component list. If I go to global, I go to components. Oh. So if I go to component list, I'm going to find it empty, which indicates that I'm still missing components. So what to do? We're going to go to the properties section, and the first thing we're going to do is put on our components. So water is our component, and the type of component is conventional, and it's identified by Aspen Plus. Aspen Plus knows this component. And we're going to have methanol. Methanol is also a conventional type of chemicals that is actually understood by Aspen Plus. Let's go to the methods. The specifications required by our question is an RTL. If you look, you're still having a half red circle. If you look again, or if you press the next button, you're going to see that the binary interactions of an RTL needs to be just clicked on. You don't need to change anything, just click on it. Now we have the properties in check and everything in check. We have our own water methanol system. Let's go back to the simulation. You can see now it's selected here. So we have three streams. We have feed and liquid and vapor. The feed stream in our process was 180 Fahrenheit, 20 psi, 50 pound-mole per hour methanol, and 50 pound-mole per hour H2O. As you can see here, we have different things. Let's start with 180 Fahrenheit, a 20 psi. As you can see, you can change the pressure and everything in it. You can have either total mole flow basis, volume, standard volume, or mass, or you can have it by composition, including the mass and mole fraction. If you look here, you can change the temperature to vapor fraction and the pressure to vapor fraction. Either one of them would give you a correct answer. So right now I have 50 pound-mole per hour water and 50 pound-mole per hour methanol. Let's go to the blocks. In our block, I'm required to operate at adiabatic conditions. So my duty is 0, which is the heat duty. The pressure is 1 atmosphere. Now let's run the process. Everything here is green and we're generating results. Now we have results available at this point. Look at this. This is the results summary. Everything that I have already inputted in the process is going to be summarized in this file. I'm just going to click on it. Okay, so let's look at the streams. Look at this, the feed, the liquid, and the vapor. If I click stream table, I'm going to have a very long stream table that actually has everything I want from the process. Liquid, vapor, the flash is mixed, the substream is mixed. Look at this, everything I require, including the entropy, the density, the average molecular weight, everything. So what about the block? You can actually create edge curves. We're going to talk about these later on. Or you can have the results here. You can see that the outlet temperature is calculated, the outlet pressure is calculated, the vapor fraction, the heat duty, the net duty, the first total liquids, and everything else. So thank you for listening to me, and I hope you actually enjoyed and got used and thought that this video is useful. I hope you read Dr. Yazan's manual. I will actually put it in the comments section. Thank you very much.